this is video number 7 for Mecanum Engine, the final sprint, and we're going to be going over the collidables. Alright, so here's the collidable class reference. So here's the just general overview. So we've got collision volume B sphere here, which is inheriting from collision volume, and that's the main driving force of the actual collision sphere, if you will. And then most of this just has to do with registration and deregistration and all that good stuff. Okay. And here's the actual templated collidable group. Of course, inheriting from a base, so we can actually pass this in using our scene and command system. Okay. So, yeah, most of this stuff is done in the header because all of these classes are actually templated. Well, not all of them, but most of them have to deal with templates, and a lot of the classes have functions that are templated. So you've got collision registration, which is actually called by all of our game objects here, and deregistration, of course, and update collision data. So this stuff is actually going to be called by our game objects in collidable. If we walk through here, we've got our collision registration command, which calls the collidable group. And then we have these collections, just like pretty much every other exable. Let's see. So we've got set collision pair and set collision self, which is called at the scene level, and those are templated. And then we've got the actual test command. So we've got test pair command, and then we have test self in here as well. So let's take a look at both of those. So test pair command is actually calling our PW mat tools to intersect, and this is doing the same. So when it's intersecting, it's going to be red. When it's not intersecting, it's going to be blue. So there's the command pattern there. What else do we have here? Okay. So I think I've just ran through all of that, so let's just see how it's actually called in Tank. No, we're going to go into the scene test first and see how all this is managed. So we've got set collision pair, and then we've got enemy and tank, enemy and good bullet, and tank and bad bullet. So we're actually terminating these collision groups because their data needs to be deleted whenever the scene is deleted. And they're templated, so it was a little bit tricky to get that to work. Alright, so we're setting these collision pairs, and in the actual objects themselves, we're just registering for collision. So setting the collider model, of course, and then let's see, so on scene entry, we register for collision, and then deregister on exit. Okay. Alright, so let's just see that in action to make sure that's all working. Alright, next scene. Get to our follow cam. Alright, so you can see in the output window, enemy collision with self, tank collision with enemy. So it does still say self because I was using frigate for the longest time, and both of these are inheriting from frigate. But tank collision with enemy, it knows what it's doing there. And obviously, as you saw in the demo before, that bullet is destroying the enemy tanks. So it says good bullet collision with enemy. So there we go. Okay, so let's go on to the visualizer, because that kind of goes hand in hand with collisions. And as you just saw in the demo, the visualizer was working correctly. So this does have a command system. I've got where did we go here? Visualizer commands working. Let's see. Visualizer .cpp and .h. Okay, cool. So this is set up as a singleton, inheriting from line 16. And what this is going to do, so it has a pointer to a single command, and it is setting the WF unit sphere once in its constructor. So we're not creating a new sphere every time, but we are creating a new visualizer command, which we're going to have to delete later. So in the execute, we actually delete the commands rather than deleting them right away. But we do delete the WF unit sphere here. We're not deleting these commands here because we actually don't get references to those commands. So, and actually, side note, deleting those commands after they've been executed actually it was previously a large source of memory leak, but actually deleting these commands helped significantly when I was swapping scenes. Okay, so what have we got here? Visualizer set up as a singleton, only creating one of those once. Let's see. Alright, I think that's about it for collision, since we saw a demonstration of these several times and the visualizer has been walked through. I don't believe I showed you the visualizer in the actual Mecanum engine, so let's just jump into that real quick. Okay. So here's the actual structure for it. So you've got the visualizer commands inheriting from collision test command base, and that's important because actually at the scene level we're going to be calling test command base to update this during the draw. So that's actually like a different call here. So if we go into scene.cpp, we have a visual broker that is executing the commands. So it's not going through the normal scene broker, it's going through the visual broker here. I don't know if we actually step through that, so let's take a look. Yeah, so it's pretty much the same as the normal scene broker, but we're executing commands on the visualizer instead. Okay, yeah, I think that does it for collisions and the visualizer. Alright.